Hello and Assalamualaikum. We continue in subtopic 10.5, which is how to solve first order ODE. So before that, we need to learn. We want to see the geometrical perspective of the first order ODE. Okay, so we take one example. There is an equation dx dt equal to x1 minus x t. So this equation we can make a geometrical view according to the axis. So the x-axis is t, y-axis is x. So how to do this? Because we don't know how to calculate x, but we can use different value of x and t to get the gradient, which is dx dt. So we can put value of x right here, and we can put value of t right here. Let's say we put the range is from for t 0 to 4, and for x 0 to 2. So for t 0 to 4 and for x 0 to 2. This is example. So for example, for 1, for t is equal to 1 and x is equal to 0.5, we put the value inside this equation and we will get the gradient. The value can be negative or positive, so you can try calculate it and you can get a gradient. For example, the gradient for this point is -1, for example. So we put a line like that. That is the gradient is -1, and we can do this for other value of x and t. So for example 1, so maybe the gradient is a little steeper. 1.5, the gradient is more steeper, and finally the gradient is infinity. Okay, so this is example. So actually when we use this equation, we will get this kind of so this is the answer, figure 10.5. So if you look at here, the gradient for each point is different, and you can see that it create a flow. It's like a flow, and it has direction. The flow has direction, and actually from here we can create multiple lines which is tangential with these gradients. So actually we call this diagram direction field. This diagram is direction field. Okay, so what happened? We can put multiple lines which is in agreement with this gradients or direction field. So we will get, for example, we have 5 lines right here, and all of them are with agreement to the direction field. Okay, so all of these answer or 5 answers are correct, because we don't know the condition, we don't know the boundary condition of this problem. Okay, so we can go to the example 10.12. So now in this problem, the condition is given. So the equation is dx dt equal to -1 over 2x. Okay, so from this equation we can create a direction field. This equation and the boundary condition in given in the example is x0 is equal to 2, and also there is another boundary condition for another line, which is x3 equal to -1. Okay, so we will create two lines according to these two boundary condition. So I'll just show you what is the answer. So actually this is the answer. Okay, this is the answer according to the example 10.2 right here. So the answer is when, if you look at here, when x is equal to 0, when t is equal to 0, x is equal to 2. So we can start the line at point 2 right here, and then following the direction field. So make sure that this line is tangential to the direction fields. So we will get this line, and this line is correct. And also the another line is x, when t is equal to 3, x should be -1. Okay, so we start we find 3 right here. When t is equal to 3, x should be -1. So it's the line should start from here, and we can draw the line according to the again direction field. And also we need to draw the another half of the line at the backward, and that line also should be tangential to the direction field. Okay, so that is for example 10.12. Okay, so hopefully you understand the concept. Actually, I want you to understand the concept of the differential equation. You get the geometrical perspective of the equation. Okay, now without further ado, I will go to the next subtopic, which is 10.5.3, which is you want to find the solution of separable DE, differential equation. Okay, so what is separable differential equation? We will learn this after this. So we will learn it right now. Let's say we have an equation, a differential equation, dx dt equal to f in terms of t and x. Okay, when we can manipulate this f function into the form, we can change it into this form, g x dx dt equal to h t. Notice the difference. F is a function of t and x, but g is a function of only x, and h is a function of only t. So when we can rearrange f function into this kind of form. It shows that the equation is a separable equation. Excuse me. So when this happen, there is a derivation you can read in the book, but I want to go straight to the answer. So when this happen, you can get that integral g x dx is equal to integral h t dt. So this is the formula you need to remember. Right. So when you get this, when it is a separable equation, you will get this. So this is only for separable equation. Okay. To understand, we go to the example. So we go to example 10.13. So we have the equation is dx dt equal to 4xt, and x is more than 0. It's bigger than 0. So how to solve this? We can separate it. So we can make it in this form. We can change it into that form. We will have g, x and ht. So what will happen is 1 over x dx dt equal to 4t. So if you realize, gx is equal to 1 over x, okay, and ht is equal to 4t. Okay, and now since we know the formula right here, so we can directly go to that formula, which is integral dx over x. Why over x? Because the equation gx is this one, and this one is equal to integration 4t dt. Okay, and then we can solve this. We can integrate it, and using the formula, when we integrate 1 over x, we will get ln x equal to 2t square plus c. We will have a constant right here. Or we can have x equal to e exponential 2t square plus c. This is equal to e 2t square ec. Okay, and also this is equal to c, another c, e 2t square, where okay, where c prime is equal to e power of c. Okay, so that's the solution. We can put c in back to the to the formula. No. So this is the final answer lah. So either this one, or this one, or this one, or this one. Okay. So there you go.